When COVID-19 first swept across Australia in 2020, Associate Professor Jiajia Zhou was racing against the clock.
We saw an opportunity using our tiny and light-emitting materials for detecting the virus.
She was part of a team at UTS that knew they had the technology. The trick was ensuring it could be modified to rapidly detect COVID-19.
This is the first generation device we make for detecting the SARS-CoV-2 antigen.
The technology was more sensitive than other tests available at the time, able to identify viral proteins at very low levels. It was also able to return a result in under 15 minutes, much faster than the standard PCR test that took several hours to process. It's the type of translational science Associate Professor Zhou is renowned for.
I naturally love solving problems, so science provides me the tools to uncover the wonder of nature.
But she started out in fundamental science, observing the characteristics of nanoparticles. Her challenge was to make nanoparticles even smaller while retaining their useful optical properties.
I found a very cool way to make the tiny and light-emitting material even more amazing.
That often means working in the dark.
Spectrum.
Her techniques turn what would normally be invisible light into something we can see.
The cell type is different.
That's enabled Associate Professor Zhou's team to create thermometers so small they can measure the temperature within living cells. The technology not only helped realize the COVID-19 rapid antigen test, but also caught the attention of a major milk producer.
They want a very sensitive and rapid method to detect the A1 milk protein.
Milk typically contains a mixture of A1 and A2 proteins, but there is a growing market for milk with just the A2 variant. Associate Professor Zhou's technology has been shown to detect the protein reliably and quickly and could be used to test for A1 contaminants throughout the production chain.
I feel the responsibility to keep pushing forward the boundary of science and technology.
Her ever-expanding list of achievements has now seen her recognized with the Pawsey Medal from the Australian Academy of Science.